Today's SAT strategy session brings us a question that talks about a landscaping company estimating the price of a job in dollars using an expression 60 plus 12 NH, where N is the number of landscapers and H is the total number of hours. They want which of the following is the best interpretation of the number 12 in the expression. And so you're looking here and you see these possible answers down here, A through D. Now the thing here is to recognize that in this problem we are talking about it's the price of a job in dollars. And so if this represents the price of a job in dollars, then we can view this as a price and see which ones don't make sense. This is how much the company charges. That might be right. This talks about a minimum of 12 landscapers working on each job. That doesn't talk about money. That talks about number of people. C talks about the price of a job. Okay. D talks about the landscaper working 12 hours a day. That has nothing to do with the cost. So you can minimize that because this has to represent $12 of something, because you're talking about dollars in general. Now you have to look at the fact that this has two variables on it. It has an N, which is the number of workers, and H, which is the number of hours, which means that it should be discussing that in the answer. If you look at C talks about the price of the job increasing $12 every hour, which is good. It talks about hours, but notice it does not talk about the number of workers, whereas A talks about per hour, which is good for each worker, and so that's what tells me that the answer is A. If that was just 12H, then it would have been C, but since it's per hour for each landscaper, N and H both are there, which is what tells me what I need to see. Other than that, talking about wrapping up this week, getting ready for your quiz tomorrow. Factoring special cases, day 1. So throughout the past 2 weeks, we've seen almost everything that's necessary to factor problems on our unit test. There are a couple more new ideas, and I put that in quotations because they're really not new ideas. They're just things you have to kind of see. They will be introduced, but we actually know how to do almost every type of factoring in this chapter. If you could just freeze your memory and make sure you remember how to do everything. Today we'll use skills called common sense and observation to factor problems that should turn out to be pretty easy to do. Let's work through some problems together real fast just to show you what the idea is. Excuse me. Here, you notice that's A and that's C. There is no B. We're looking for numbers that multiply to be negative 36 and add to be 0. Now, what we learned before is that when it adds to be 0, that the numbers should be opposite of each other, which means when you go to make your tree for 36, because it adds to be 0, we are looking for 6 and 6. And that one of the 6's is positive and the other 6 is negative, because that's the only way you get a 0 whenever you add them. And so with that said, we now put 9x over 9x with 6 here and 6 there. Sorry, negative 6 there. Both of these can be divided by 3, which puts 3x over 2 and 3x over negative 2, which in the end gives me these two answers. So it's not as bad. It's just something you got to be aware of. Here we're looking for numbers again. That's an x squared. It's A and a C. So we have multiplies equal negative 100. Adds again to be 0. The fact that it adds to be 0 because there's no B there means that we're looking for the same number that makes 100, which is 10 and 10. Because it adds to be 0, it means that one of these is positive and one of these is negative. And so what we will do there is take this x and put it on top of 10 and negative 10. And because neither of these can be reduced, we're looking at x plus 10 and x minus 10. Looking at question C. Factor 4x squared minus 25. Here we're looking for numbers that make negative 100 and again add to be 0. Again, we just found out that those numbers are 10 and 10 with one positive and one negative. So we put 4x over 10 and 4x over negative 10 based off of what we learned. Reducing these, we get 2x over 5 and 2x over negative 5, which means my answers are 2x plus 5 and 2x minus 5. And the last one multiplies to make whatever 16 times 9 is. Let's see. Which is 144. Sorry, negative 144. And adds again to be 0 because there's no x term. From there, we are looking for the numbers that multiply to make 144. They are the same, and those two numbers are 12 and 12, with one being positive, one being negative. Taking this term, putting 16x over 12, 16x over negative 12, both of these can be reduced by 4, giving us 4x over 3 and 4x over negative 3, meaning that my answers are 4x plus 3 and 4x minus 3. Now, as you read along on your sheet, it says, look back at the problems at the answers. We should notice something special about how they are connected. Looking at this, talked about the middle problems eliminating each other, and what you should notice when you look at this is that 3 times 3 is 9, 2 times 2 is 4, 1 times 1 is 1, or x times x is x squared, 10 times 10 is 100, 2 times 2 is 4, 5 times 5 is 25, 4 times 4 is 16, 3 times 3 is 9, and so it kind of gives us something there where we can actually kind of see what we would do before we even have to write it out. We can initiate the shortcut that we're talking about if we recognize that the conditions exist, and here are the two conditions. Number one, both terms should be perfect squares. For example, go back to A, 9 is a perfect square. That's 3 times 3, 2 times 2, 1 times 1, 10 times 10. And then, of course, on the other page, we had 2 times 2, 5 times 5, 4 times 4, 3 times 3. So again, the first condition is that you have perfect squares. The second is that you have a subtraction sign between them. And if you see those two conditions, if you observe, which is why I said your observation was a tool today, but if you observe that condition, then you can apply your common sense and go straight to the answer. And so what we notice is that both of those parentheses are pretty much the same, except there's just a plus in one and a minus in the other one. So let's do some practice and review before moving on to class practice using our observation and common sense if we can. Factor x squared minus 144. Before I go to do the work, I recognize that this is x times x because it's a perfect square. That is 12 times 12. And there's a minus between, which means that all I have to do is put x and 12, right? Because that's x times x, 12 times 12, with a plus and minus in between. Now, if you don't recognize this skill, you do not have to do that. As it says up here, it's not necessary that you use the shortcut, but it does save you time if you get faster with it to just recognize it's x plus 12, x minus 12, and finish it off. Look at B. 9x squared minus 49. Before I go to do anything crazy, I notice that it only has two terms, and I want to check something real fast. This is 3 times 3, x times x, 7 times 7. So what I'm going to do is put 3x plus 7 and 3x minus 7 and be done with it. Again, you can go through and do the multiplies to equal whatever and adds to be 0, but I think it's much nicer if you learn to use that shortcut, because notice how fast we got through it. This here, once I look at it and I see two terms, that's 10 times 10, 11 times 11 with nothing in the middle but a minus, which is perfect. And so what we do now is we recognize that this is 10x plus 11 and 10x minus 11. So those are where it works. Look at letter D. You have 8x squared minus 10x. We go to use the trick, but 8 is not a perfect square. Do not think that 4 times 4 is 8. 4 times 4 is 16. Just like 5 times 5 is not 10. That's actually 25. So this is something different. This is actually a review question in which we look at 8 and 10 and find out we can take out a 2. We look at both of these and realize we can take off an x. And then we make a distributive property problem where 8 divided by 2 is 4. With 1x left over, copy or minus, 10 divided by 2 is 5, with no x's left over. So this is where the unit gets interesting, because if you're not careful, then you are going to make some major mistakes, or not major mistakes, but a lot of small mistakes that could cost you some good amount of points. E. This can't be a shortcut because it's got three terms, so this means I'm going to factor as usual. Multiplies to make negative 27, adds to make 26, 1 times 27, 3 times 9, the only numbers there. Remember, this means the signs are different, and this means that my big side is positive. The ones that make 26 are negative 1 and positive 27. From there, we take that 9x, put it on top of both fractions with negative 1 here, positive 27 there. These can both be divided by 9, which makes it x over 3, and our final answer being 9x minus 1 and x plus 3. Alright. And F. Again, this can't be a special situation because it's got 3 terms. Here we're looking for numbers that multiply to be negative 20 and add to be 1. With that being said, we make our tree for 20, 1 and 20, 2 and 10, 4 and 5. The fact that this is a negative 20 means the signs are different. This is a positive 1, which means that this side is going to be positive and that side is going to be negative. The ones that make 1 are negative 4 and positive 5. So again, you take this 10x and put it on top. Negative 4 here, 5 over there. Reducing both fractions, 10 divided by 4 is 5 over 2, or negative 2. 10 over 5 turns into 2x over 1, because both of those can be divided by 5. And you end up with the answer of 5x minus 2 and 2x plus 1. Easy enough. Get the worksheet from me, get some practice, ask questions, and again, prepare for that quiz tomorrow. Remember that if you don't perfect the shortcut, it doesn't mean you can't answer the question, because you just have to use the same strategy I used at the beginning of class. Other than that, again, make sure you get as much out of this as you can. And again, make sure you communicate if there's any issues that you're having.